CatBoost, short for categorical boosting, is a powerful gradient boosting algorithm designed to handle categorical data efficiently. It is known for its robustness, ease of use, and high performance in machine learning tasks. CatBoost handles categorical features natively, eliminating the need for manual preprocessing like one-hot encoding. It uses a novel method called ordered target encoding. Ordered boosting is a technique that reduces overfitting by using a permutation-based approach. During training, this ensures the model generalizes well to unseen data. CatBoost supports GPU acceleration, making it significantly faster for large datasets compared to CPU-based implementations. CatBoost provides built-in tools like feature importance and SHAP values for model interpretation, helping users understand the model's decisions. Ordered boosting uses a permutation-based approach to reduce overfitting. The data is shuffled, and the model is trained on different subsets. CatBoost outperforms XGBoost and LightGBM in handling categorical data, is less prone to overfitting, and provides built-in support for missing values and categorical features. Let's learn how CatBoost classification works step by step using a simple example of predicting whether students will pass or fail a class. Here is our dataset. We have 5 students, and we want to predict whether they will pass or fail based on their homework submission rate, study hours, and favorite subject. CatBoost handles categorical data using a technique called ordered target encoding. It converts categorical features into numerical values based on the target variable. We start with an initial prediction. Since we don't know much about the students yet, we assume everyone has a 60% chance of passing. Next, we calculate the gradient, which tells us how much we should adjust our prediction to reduce the mistake. For each student, the gradient is the difference between the predicted probability and the actual result. Here are the gradients for each student. For example, for student 1, the gradient is 0.6 minus 1, which equals minus 0.4. The Hessian tells us how fast the error is changing. It helps us decide how big of a step to take when adjusting our predictions. Now, we build the first decision tree. The tree splits the data based on the features to reduce the error. CatBoost uses a symmetric tree structure, which helps in handling categorical features efficiently. After building the tree, we update our predictions by adding the tree's output to the initial prediction. We repeat the process, adding more trees to correct the mistakes of the previous trees. The final prediction is the sum of all the tree's outputs. Here are the final predictions. For example, student 1 has a 91% chance of passing. So we predict they will pass. Let's learn how CatBoost Regression works step by step using a simple example of predicting house prices based on features like size, location, and number of rooms. Here is our dataset. We have 5 houses, and we want to predict their prices based on size, location, and number of rooms. CatBoost handles categorical data using a technique called ordered target encoding. It converts categorical features into numerical values based on the target variable. We start with an initial prediction. Since we don't know much about the houses yet, we assume the average price of all houses is the initial prediction. Next, we calculate the residuals, which are the differences between the actual prices and the initial predictions. Here are the residuals for each house. For example, house 1 has a residual of -$70K, meaning the initial prediction was $70,000 higher than the actual price. Now, we build the first decision tree. The tree splits the data based on the features to predict the residuals. After building the tree, we update our predictions by adding the tree's output to the initial prediction. We repeat the process, adding more trees to correct the mistakes of the previous trees. The final prediction is the sum of the initial prediction and all the trees' outputs. Here are the final predictions. For example, house 1 is predicted to cost $310,000, which is close to the actual price of $300,000. Let's explore the advantages and disadvantages of the CatBoost algorithm. Here's a table summarizing the key advantages and disadvantages of CatBoost. CatBoost excels at handling categorical data. It automatically encodes categorical features without requiring manual preprocessing. However, for high cardinality categorical features, it may consume more memory. CatBoost is faster than traditional gradient boosting algorithms due to its efficient implementation. However, it is generally slower than light GBM for very large datasets. CatBoost achieves high accuracy with minimal hyperparameter tuning, making it a popular choice for machine learning tasks. However, it can overfit if regularization parameters are not properly set. CatBoost is resistant to overfitting due to its ordered boosting technique, which reduces bias. However, it may still overfit on noisy datasets if not carefully tuned. CatBoost provides feature importance scores, making it more interpretable than some other boosting algorithms. However, it is still less interpretable than simpler models like linear regression or decision trees. CatBoost automatically handles missing data without requiring pre-processing, making it convenient for real-world datasets. However, it may not perform well with highly sparse datasets. CatBoost is excellent for datasets with categorical features and missing values, making it a strong choice for real-world applications. However, for purely numerical datasets, it may be less efficient compared to light GBM. Let's summarize the key points about CatBoost. A powerful gradient boosting algorithm designed for handling categorical data. CatBoost automatically handles categorical features without requiring pre-processing like one-hot encoding. It uses ordered target encoding to avoid target leakage, making it robust for handling categorical data. CatBoost uses ordered boosting, which shuffles data to reduce overfitting and improve generalization. It supports GPU acceleration, making it significantly faster for large datasets compared to CPU-based implementations. CatBoost provides tools like feature importance and SHAP values for better model interpretability. CatBoost can handle missing values in the dataset without requiring imputation. CatBoost often achieves high accuracy with less hyperparameter tuning compared to other algorithms. It uses less memory than XGBoost, making it more scalable for large datasets. CatBoost is optimized for large datasets and may not perform as well on very small datasets. Like other boosting algorithms, CatBoost is less interpretable compared to simpler models like linear regression. I hope you found this video helpful. If you enjoyed it, please give it a thumbs up, subscribe to the channel, leave a comment, and share it with your friends. Your support means a lot. See you in the next video.